Hello friends, good afternoon everyone. I am fine. How are you? I hope you will be fine. Welcome back in my channel, Dr.Satendra Kumar. Dear friends, if you want this type of videos related to mathematics for higher level, then you need to subscribe, share and like my videos and my channel. Today we will discuss complex variable integration, in which there are some proof of Cauchy integral formula and its derivative. Now first, Cauchy integral formula. Cauchy integral formula has been come MTU 2012, GBTU 2014, and 13, and MJPRU 2020. Now Cauchy integral formula statement. If fz is analytic within and on closed contour C except a point z is equal to A, then fa equal to 1 upon 2 pi I integration over C fz dz upon z minus A. Proof. Let phi z equal to fz upon z minus A, which is analytic at every point within C except z equal to A. We draw a circle C1 with A as center and radius rho such that C lies entirely inside C, such that C1 lies entirely inside C. Thus, we can say f phi z is analytic in the region between C and C1 curve. Now we draw the figure. Here is the center of circle C1. A rho is radius it circle which is surrounded a circle C1, a circle C. Now point A1, B1, now B2, A2, this is C curve, this is the C1 circle. Now we consider a function phi z fz upon z minus a, which is analytic in the annulus, which is that is between circle C and circle C1. Then we can apply Cauchy theorem in this annulus by Cauchy theorem between C and C1 annulus. We have integration over C phi z dz plus integration over A1 B1 phi z dz minus integration over C1 phi z dz plus integration over B2 A2 phi z dz. This is equal to 0. Since A1 B1 and B2 A2 both are equal but opposite in sign, therefore they are cancelled to each other. Now integration over contour C, putting the value of phi z fz upon z minus a dz equal integration over contour C1 fz upon z minus a dz. This is considered equation number first. Now the equation of circle C1. Circle C1 z minus a modulus is equal to rho, that is z minus a is equal to rho e to the power I theta. Now dz is equal to rho I e to the power I theta d theta. Therefore integration over contour C1 fz dz upon z minus a, this is equal to, now contour integral convert into circle integral, then limit 0 to 2 pi fz. Now putting the value of z, f a plus rho e to the power I theta. Now dz rho I e to the power I theta d theta upon z minus a, that is rho e to the power I theta. Now rho e to the power I theta cancel. Then we get I integral limit 0 to 2 pi f a plus rho e to the power I theta d theta. In comparison of circle C, that is in comparing of circle C, circle C1 is very small, is very small. That is the radius of circle C1 is very small, that is rho tending to 0. Now integration over contour C1 fz dz upon z minus a, this is equal to I integral limit 0 to pi f a plus 0 d theta, this is equal to I f a theta limit 0 to 2 pi, this is equal to 2 pi I f a. This is the value of integration over contour C1 fz dz upon z minus a. Putting this value in equation number first, we get from equation number first integration over contour C fz dz upon z minus a, this is equal to 2 pi I fa, implies fa is equal to 1 upon 2 pi I integration over contour c fz dz upon z minus a. This is the complete proof of Cauchy's integral formula. Now another method, a little from equation. First, integration over contour c fz dz upon z minus a. Now subtract both sides, integrate over contour c1 fa dz upon z minus a. This is equal to integration over c1 fz minus fa upon z minus a dz. Taking modulus both sides, integration over contour c fz upon z minus a minus fa integration over contour c1 dz upon z minus a modulus. This is equal to modulus integral over contour c1 fz minus fa upon z minus a dz. This is represented by equation number 2. First we calculate the value of integral over contour c1 dz upon z minus a. Now since integration over contour c1 dz upon z minus a, put z minus a is equal to rho e की power I theta, dz is equal to rho I e to the power I theta d theta. Now putting the value of this integration, convert into circle integral dz rho I e to the power I theta d theta upon rho e to the power I theta. This cancel by this. This equal to I d theta limit 0 to 2 pi. Therefore integration of contour c1 dz upon z minus a, this is equal to I theta limit 0 to 2 pi. This is equal to 2 pi I. Now putting the value of this in equation number 2. We take right hand side of equation number 2. Integration over contour c1 fz minus fa upon z minus a, total integration. This is equal to lesser equal to fz minus fa modulus integration over contour dz modulus upon z minus a modulus by magnitude property. Since fz is analytic, implies it will be differentiable at z is equal to a, implies it will be continuous. We know that every differential function is continuous always, that is, it will be continuous. Every continuous function is bounded always. Now definition of continuity, fz minus fa modulus lesser epsilon. Now putting the in above equation, lesser equal epsilon integration over c dz modulus. Now z minus a, this is equal to rho, z minus a modulus is equal to rho. Now lesser equal rho upon epsilon, epsilon upon rho, integration over contour C, over contour C1, the value of dz modulus is equal to 2 pi rho cancel by this. Since epsilon is very small, tending to 0, this is equal to lesser equal to 0, integration over C1 fz minus fa dz upon z minus a modulus value lesser equal to 0. It is impossible. Imply that integration over contour C1 fz minus fa upon z minus a dz will be 0. Since the magnitude value cannot be negative, therefore the value of this will equal to 0. Now putting the value of right hand side and integration over contour C1 dz upon z minus a in equation number 2, we get, now from equation number 2, integration over C1 integration over C fz z minus a dz minus 2 pi I fa modulus, this is equal to 0, this is equal to integration over C fz dz upon z minus a, this is equal to 2 pi I fa, that is fa, this is equal to 1 upon 2 pi I integration over contour C fz dz upon z minus a. This is the another method of Cauchy integral formula. Now next theorem, Cauchy integral formula, Cauchy integral formula for derivative of an analytic function. This is the heading. Now statement, if fz is analytic, if fz is analytic within and on closed contour C except z is equal to a, then f dash a is equal to 1 upon 2 pi integration over C fz dz upon z minus a square. Okay, student. Proof. In this derivative, the figure will same as Cauchy integral formula. Proof. Okay. Since we know that Cauchy integral formula, since we know that Cauchy integral formula at point z equal to a, fa is equal to 1 upon 2 pi I integration over C fz dz upon z minus a. This is equation first. Already proved in above theorem. A is a point in the contour where function is not analytic. then the neighborhood point of the given point A, let z is equal to a plus h, is neighborhood point of point z is equal to a. Now similarly we can write the value of the function at point neighborhood point f a plus h, that is f a plus h is equal to 1 upon 2 pi I integration over c f z dz upon z minus a minus h. This is equation number 2. Now we subtract equation number first from equation number 2. That is equation first subtracted by from equation number 2, fa plus h minus fa, this is equal to 1 upon 2 pi integration over c bracket 1 upon z minus a minus h minus 1 upon z minus a bracket close fz dz 1 upon 2 pi I integration over c taking LCM z minus a minus h. Now z minus a minus z plus a plus h fz dz. Now z cancel by z and a cancel by h. Now here h is constant. Now h divide both sides, fa plus h minus fa upon h, this is equal to 1 upon 2 pi I integration c fz dz upon z minus a minus h. Now taking limit s tending to both sides. Okay student, principle, the left hand side of equation is a derivative of function at z is equal to a point. This is equal to 1 upon 2 pi I integration over c. Now putting h is equal to 0, fz dz upon z minus a as well as and z minus a minus 0, that is f dash a is equal to 1 upon 2 pi I integration over c fz dz upon z minus a whole square. Okay student. Now next theorem. Cauchy integral formula for nth derivative of an analytic function. Now we can write direct theorem. If fz is analytic, fz is analytic within and on closed contour C except z is equal to a, then f and a is equal to 1 upon 2 pi I integration over contour C, factorial n here, fn is equal to factorial n upon 2 pi I integration over contour C fz dz upon z minus a whole power n plus 1 has been come AKTU 2016. Proof or answer. This theorem is proved by mathematical method, induction method. Here we apply mathematical induction method. Let theorem is true for n is equal to m. That is fma equal to factorial m upon 2 pi I integration over control c fz dz upon z minus a whole power m plus 1. This is the value of this is the value of derivative at point z is equal to a. Similarly, we can calculate the value of derivative mth derivative of neighborhood point a plus h. Similarly, for NBD point a plus h, we can write fm a plus h equal to factorial m 2 pi I integration over c fz dz upon z minus a minus h whole power m plus 1. This is equation first and this is equation 2. Equation first is subtracted by equation number second. That is fm a plus h minus fma. This is equal to 1 upon 2 pi I common integration over c 1 upon z minus a minus h whole power m plus 1 minus 1 upon z minus a whole power m plus 1 fz dz implies fm a plus h minus fm a equal 1 upon 2 pi I integration over c bracket. Now taking the common z minus a whole power m plus 1. Now here 1 minus h upon z minus a whole power minus m minus 1 bracket close fz upon z minus a whole power m plus 1 dz. Now taking common z minus a whole power m plus 1. Now here 1 and here 1 minus h whole power 1 minus h upon z minus a whole power minus m minus 1. Now we can apply binomial expansion here. That is 1 upon 2 pi I integration over c 1 upon z minus a whole power m plus 1 bracket 1 plus m plus 1 h z minus a plus m plus 1 m plus 2 factorial 2 h square z minus a whole square or plus up to dot minus 1 fz dz. Now minus 1 cancel by plus 1. Okay. Now taking common, now factorial m and factorial m as well as from equation number first and equation number 2. Now taking here h into m plus 1 upon z minus a. Now m plus 1 factorial m h integration c 1 upon z minus a whole power m plus 2. Now z minus a 1 power here and m power m plus 1 here bracket 1 plus m plus 2 into h factorial 2 z minus a plus up to dot bracket fz dz upon 2m pi I. Now h divide both sides. Fm a plus h minus Fm a upon h. This is equal to factorial m plus 1 2 pi I integration over c 1 upon z minus a whole power m plus 2 1 plus m plus 2 h z minus a plus up to dot fz dz. Now taking limit h tending to 0. With the help of the first derivative, this is the value of fm plus 1 a. This is equal to factorial m plus 1 2 pi I integration over c 1 upon z minus a whole power m plus 2 bracket 1 plus 0 plus up to dot fz dz. Now this is equal to factorial m plus 1 upon 2 pi I integration over c fz dz upon z minus a whole power m plus 2. Okay student, here we consider the theorem is true for n is equal to m. Similarly, it will be true for n is equal to m plus 1. Now we can say by mathematical induction method, the theorem is true for every number n. That is fna equal to factorial n upon 2 pi I integration over c fz dz upon z minus a whole power n plus 1. Okay student.